There isn't just one and only solution suitable for vehicles running on track, but there are important principles that you should definitely keep in mind. Which of the rail axles of your vehicle should be driving, and which of the wheels should be braked? For the advantage of gradability and towability, you would make all axles driven, but it has a direct influence on the cost of the vehicle. You would not only need 6 motors, but also large-size pump to supply them. Technical regulations for road rail vehicles are provided by EN 15746 standard. You won't find requirements on the number of driven axles of wheels. You should make your decision based on the vehicle purpose and load calculations. We decided that single axle driven is sufficient for this vehicle, as it is not supposed to tow any trailers. Where do we need to place brakes? Braking systems performance is regulated by standards, and they must be capable of stopping the vehicle within the required distance using either of 2 independent systems. One system is used for regular service braking while driving, and the other is a parking brake. The standard does not specify which axles should be braked. For optimal braking performance, we would typically brake the most heavily loaded axle, as it can maintain the highest friction force, and our axle load calculations show that it is the front axle. It would be ideal to put drive and both types of brakes on the most loaded axle, but it is not feasible due to space limitations. We decided to install the service brakes on the front axle. You can use our Excel calculator to calculate your vehicle's axle loads, driving power, and braking distance. It is available on INBI Euro website. Now, let's get back to the brakes. Service brake is hydraulically activated and released by springs. The parking brake is placed on the rear axle, and it is operated by spring-activated, air-release chamber. How do we connect it now? The wheels require closed-loop system as they need to drive both directions, and we aim to minimize power losses in the circuit. A variable discharge piston pump is installed on the engine's power takeoff. We connect the pump to the motors in a parallel configuration. The pump's discharge capacity should be sized to match the combined capacity of both motors at the vehicle's maximum design speed. However, there's one problem. When one of the driven wheels loses contact with the rail, it begins to skid and takes all the oil flow. As a result, the other motor becomes unable to drive the vehicle. We can mitigate this problem by using a flow divider before the wheels. There are various types of dividers, each with its own pros and cons. To maintain system symmetry, we can use single-direction dividers with bypass flow towards the pump on both lines. This solution is suitable for slow-moving vehicles, as the flow divider causes a higher pressure drop at increased flow rates. The pressure drop in the motor supply line is the cost of synchronization that must be accepted. Another option is to connect the motors in series. If one of the motors loses contact, it won't skid because the oil must pass through the other motor first. The pressure difference generated by the pump is divided between the 2 motors, reducing the effective torque of each motor. As a result, the vehicle's gradability is lower compared to a parallel configuration. However, this remains a very efficient solution for vehicles with minimal towing demands. How does it perform in long-time operation? Charge pump capacity is sized for roughly 10% of the main pump. This means that 10 times more oil circulates between the pump and the motors and heats up. We need to flush some amount of oil from the closed circuit to the tank. Piloted shuttle valve connected to both lines of the motor supply will always select to drain the return line to tank. Okay, we've established the initial concept for the tubing. What about the oil filtration? Again, there are several options. Option 1, a suction filter on the charge pump inlet installed on the oil tank. The downside is that it causes high resistance and charge pump cavitation during cold starts in winter due to the higher viscosity of cold oil. This is not ideal for mobile machines. Option 2, pressure filters on motor supply tubes. They catch all the contamination efficiently as long as we drive forward and release all the dirt as soon as we drive backwards. You can use bidirectional version to mitigate this issue. Anyway, filters in the main flow of closed circuit would have to be sized for the entire flow of the oil. Even large size filters still cause pressure drop and degrade the energy efficiency of the system. From a maintenance point of view, they are not convenient on mobile machines, as every replacement increases the risk of contamination ingress. We can put the filter at the charge pump outlet, parallel with charge pump relief valve, protecting the pump and setting the charge pressure. This solution provides partial flow filtration, usually considered as sufficient. What does the partial mean exactly, and how much of oil goes through the filter at these conditions? The oil the charge pump takes from the tank must return to tank at same amount. This would mean no oil flows through the filter as long as the hot oil flush shuttle stays closed. As soon as it opens, the amount of oil filtered is equal the oil flow through the shuttle. Charge pump relief closes because hot oil relief is set for lower pressure, and whole the charge oil goes through the filter. The oil filtration strategy depends on the machine manufacturer, and some pump models come with a built-in full charge filtration option like this one. The pump-mounted filter draws whole charge oil before it goes to either to circuit or to the relief valve, so regardless of the hot flush position, the entire charge oil is filtered. We encourage you to consider these guidelines while designing your vehicle. InBeuro, customized vehicle solutions.